Gulf of Oman, February 28, 2026. Global media is losing its collective mind over Operation Epic Fury. The news anchors are sweating in their studios. The chyrons flash bright red across your screen. Headlines scream the casualty count with breathless, frantic energy. 11 core Iranian warships, wiped off the face of the earth in the first 48 hours. $10 billion in military hardware, vaporized into floating slag. The media calls it a massive strategic victory. Pundits who have never worn a uniform or solved a basic physics equation look at the cameras and declare that the United States has won the day. But they don't understand the equation. They never do. They look at the fire, but they completely ignore the friction. They are entirely blind to the ruthless logistics that made those explosions physically possible. To understand those logistics, you have to look at the trap the enemy built for us. For 30 years, the Islamic Revolutionary Guard Corps prepared for this exact conflict. They knew they couldn't compete in a traditional industrial arms race, so they built their trap with asymmetric mathematics. They amassed over 1,500 composite fast attack craft, stealth midget submarines, and an aerial armada of suicide drones. The plan was a calculus of absolute saturation. Drag the United States fleet into a maritime choke point, attack the waterline with boats, and swarm the radar arrays with drones. They wanted to exhaust the Aegis combat system, forcing us to trade $2 million interceptor missiles for cheap plastic targets. Bleed the magazines dry before the real fight even started. But the trap never sprang. There was no bloody close-quarters firefight on the water. The drone swarms never clouded the sky. The entire high-speed armada died before they could even draw their weapons. How do you neutralize 1,500 boats running at 65 knots and hundreds of flying bombs without chasing a single one of them? How does the United States Navy wipe out 11 major warships without giving the enemy a chance to see the silhouette of our hulls? Today, we ignore the political speeches. We look at the geometry of the battlespace. We dissect the merciless calculus of the kill chain. We look at the thermodynamic reality of modern naval warfare. If you prefer the ruthless logic of American engineering over the empty noise of political theater, hit the proud button, subscribe, and let's get to work. To understand the slaughter, you have to look away from the guns and look at the fuel reserve. How do you dismantle a trap consisting of 1,500 attack boats, ripping across the water at 65 knots, and hundreds of suicide drones preparing to swarm? Amateurs pull the trigger. They try to match speed with speed. They engage in a desperate race to the bottom of the attrition curve, hoping they simply have more bullets than the enemy has targets. We are engineers. We don't shoot the weapons. We aim for their stomach. Take a supercar as an example. Its engine generates unbelievable horsepower. But at top speed, with the throttle wide open, it burns its entire fuel reserve in exactly 12 minutes. 12 minutes of glory. But without a constant supply line, that multi-million-dollar machine is just an expensive paperweight on the side of the road. Iran's composite boats and drone swarms face this exact paradox. They have the speed and they have the volume, but they are absolute prisoners of physics. Pushing 65 knots on water is not like flying through the air. Water is roughly 800 times denser than the atmosphere. Think about driving a tactical vehicle at 60 knots and sticking your hand out the window. The air pushes back, but you can hold your arms steady. Now imagine sticking your hand out of a speedboat into the water at that exact same speed. The density of the water would snap your wrist instantly. That is hydrodynamic friction. Moving through water at 65 knots is a brutal, violent wrestling match against the ocean itself. To overcome that massive wall of water resistance, you need massive engines. Massive engines require massive amounts of fuel. Fuel adds weight to the hull. Weight pushes the hull deeper into the water, which in turn increases the surface area dragging against the ocean. It is a vicious, inescapable cycle of thermodynamic penalty. Because of this, the operational range of these fast attack craft is pathetically short. The suicide drones face the exact same physical constraint. To reach the United States fleet in deep water, those Shaheed-style munitions require heavy launch catapults and massive fuel reserves. They don't magically spawn in the middle of the ocean. For this two-tiered swarm to extend its tentacles into the open water, it must be chained to a logistical umbilical cord. Let's follow that cord. Look at the other end of the tether. You will find the INS Makran. It started its life as a commercial crude oil tanker. Now, it is 121,000 tons of double-hulled steel. It's a floating refueling hub, a lumbering ammo dump. It is the only beating heart keeping thousands of attack boats alive offshore, holding millions of gallons of marine diesel. Right next to it sits the IRIS Shahid Bagheri, another converted commercial behemoth, boasting a 787-foot angled flight deck. It is a floating hive, packed to the brim with hundreds of suicide drones, the launch pad for the aerial nightmare. These massive, slow-moving ships are the Achilles heel of the entire 30-year asymmetric strategy. Do the math. Kill the heart. The limbs rot. Sever this 121,000-ton stomach, and the energy equation collapses instantly. Sink the INS Makran, and 1,500 boats automatically stall out. Sink the 787-foot flight deck of the Bagheri, and hundreds of drones burn in their crates before they ever spin a propeller. The killer swarm instantly turns into drifting, lifeless tombs in the Gulf of Oman. But knowing where the heart is doesn't mean you can reach it. To kill a 121,000-ton giant and a floating drone hive without getting bitten, the United States Navy had to trade the knife fight for the void. How do you smash that logistical stomach? Without getting tangled up with a 65-knot swarm or triggering a mass drone launch. What did the United States Navy trade to win this fight without taking a single casualty? We refuse the knife fight. We exploit the void. We call it standoff range, and the defining weapon of this battle space isn't a short-range deck gun, it's the Tomahawk cruise missile, preloaded in the VLS on Arleigh Burke-class destroyers. This weapon is the ultimate expression of distance dictating terms. It allows the United States fleet to stand hundreds of nautical miles away from the target. Look at the physics of range. The engineering trade-off here is speed for absolute distance. Look inside the hull of the Tomahawk. It doesn't use a massive rocket booster for sustained flight. After the initial launch, it deploys wings and fires up a highly efficient turbofan engine. It breathes air. It sips aviation fuel almost exactly like a commercial airliner. Because of this, it flies subsonic, roughly Mach 0.74. Everyone in the media obsesses over hypersonic missiles, but pushing an airframe to Mach 5 generates immense thermal friction and burns fuel at an astronomical rate. That severely limits your effective range. We don't need to get to the target in 3 minutes. We need to deliver a 1,000-pound warhead from 1,000 nautical miles away. By utilizing subsonic efficiency, the safety of the launch platform is absolute. Sitting on the outer edge of the battle space, the Aegis combat system completely neutralizes the enemy's tactical advantage. The enemy cannot swarm what they cannot reach. Your steel hull never enters their radar horizon. But this exact safety creates a geometric paradox. Firing a projectile from hundreds of nautical miles away means your missile is inherently blind for most of its journey. Think about standing on a perfectly flat beach, watching a ship sail away until it sinks below the horizon. The Earth is a sphere. It curves. Radar waves travel in straight lines. You can pump megawatts of power through an Aegis radar array, but electromagnetic waves travel in straight lines. And the planet is a sphere. You cannot bend a radar beam around the Earth. Push past the local horizon, and the physical mass of the planet becomes an impenetrable shield. At standoff distances, the INS Makran and the Shahid Bagheri are completely swallowed by the curvature. And they aren't just passively hiding out there in the void, they are actively playing dead. They've pulled the plug on their AIS transponders, imposing strict emission control, to ghost their way through heavy commercial shipping lanes. You hold a kinetic sledgehammer. A Tomahawk can use its inertial navigation system and GPS to fly completely blind to a specific coordinate grid on the map. But the Makran isn't a static concrete bunker. It is a moving target. If you fire a Tomahawk at its current coordinates, from hundreds of nautical miles away, by the time the missile arrives an hour later, that 121,000-ton ship has moved several nautical miles. How do you drop this sledgehammer precisely on a hiding, moving target that your launching ship cannot even physically see? A sledgehammer is useless if the wielder is blind. To guide that kinetic energy across hundreds of nautical miles, the Navy had to ignite the most ruthless machine ever built, the tactical kill chain. You do not simply fire a Tomahawk into Iranian coastal waters and expect it to survive. Let's look at the hardware. The 121,000-ton Makran and the drone-carrying Bagheri are converted commercial hulls. They are not proper destroyers. Their organic point defenses are weak, relying mostly on short-range Mehrab and Kosar missiles. They cannot physically stop a coordinated standoff strike on their own. To survive, they rely entirely on the land-based coastal umbrella protecting the ports of Bandar Abbas and Chabahar. This umbrella is a multi-layered anti-access/area denial dome, E-2D. It is a thick, lethal wall of electromagnetic radiation and kinetic interceptors. Searching early warning radars. Coastal defense cruise missiles hidden in the mountains. Long-range surface-to-air missile systems like the Bavar 373, the Khordad 15, and the Mersad ready to fire. Fire a projectile on a simple, straight trajectory, and this coastal radar net will see it coming and swat it out of the sky. To deliver the kinetic sledgehammer, we have to dismantle that wall. A kill chain is a sequence. Break one link, the weapon misses. Execute every link perfectly, and the enemy dies before they even slip their mooring lines. Warfare in 2026 is a data management process. Before the kinetic weapons arrive, the electronic weapons pave the way. EA-18G Growlers push into the airspace. Their advanced ALQ jamming pods go active. We do not shoot bullets, we fire energy. We flood their receivers with digital noise. We force a lethal mathematical dilemma onto the commanders operating the Bavar 373 and Khordad 15 batteries. If they turn off their coastal radars to hide, the fleet they are supposed to protect is left completely naked. But if they panic and turn their radars on full power to burn through our jamming, they paint a massive electromagnetic bullseye on their own foreheads. The moment they emit a radar signal, the AGM-88 HARM anti-radiation missile locks onto that exact emission, rides the beam down, and blows the emitter to hell. The coastal umbrella collapses. The electromagnetic spectrum is ours. Once that door is kicked open, the sensor platforms move in to exploit the void. With the coastal air defense radars blinded or destroyed, F-35C Lightning II squadrons slip through the radiation gaps. Their extremely low radar cross-section allows them to hover inside the danger zone like ghosts. Below them, P-8A Poseidon maritime patrol aircraft sweep the littorals, hunting the acoustic signatures of stealth midget subs. They map the piers. They find the 121,000-ton INS Makran sitting at Bandar Abbas. They find the drone carrier Shahid Bagheri. They lock the exact real-time coordinates of the anchored fleet. But raw data is useless without a processor to weave it together. This targeting data doesn't just float in the ether. Orbiting high above the Arabian Sea, E-2D Advanced Hawkeyes step in as the ultimate airborne quarterbacks. They act as the digital router. They fuse the telemetry data from the F-35s, the sub-hunting data from the P-8As, and the jamming data from the Growlers. They pump those refined coordinates back to the fleet through the Link 16 network. The geometry of the battlespace becomes totally transparent. The grid is set, the targets are painted. Now, the fleet brings the hammer down. Coordinates locked, the sledgehammer finally swings. And in American naval doctrine, the first shooters at sea are always the Tomahawks. From a safe distance, Arleigh Burke-class destroyers spit fire. Vertical launch hatches blow open. Maritime strike Tomahawks launch and immediately go sea skimming. They ride just feet above the wave tops, hiding beneath the curvature of the Earth until the final, fatal seconds of flight. But the Navy doesn't just punch from below, it crushes from above. Because the Growlers already dismantled the Bavar 373 and Khordad 15 coastal batteries, the Iranian ships are defenseless. Their onboard short-range Marab missiles cannot track the incoming sea-skimming threat in time. Simultaneously, operating in the high-altitude sanctuary created by the electronic warfare, F/A-18E/F Super Hornets rush in, acting as heavy bomb trucks. They drop in on the E-2D's refined grid, raining down 2,000-pound JDAMs directly onto the ports. Kinetic energy meets steel. Thousands of pounds of high explosives detonate inside the enclosed compartments of the Iranian ships. The 121,000-ton INS Makran burns violently and is destroyed right at the Bandar Abbas pier. The 40,000-ton drone carrier Shahid Bagheri, along with its 787-foot flight deck and entire payload of suicide drones, is struck within hours and turns to twisted scrap. The Jamaran-class corvette sinks straight to the bottom at the Chabahar pier. An operational stealth submarine is erased before it can even dive. The logistical stomach is completely severed. The grid snaps shut. The math is finalized. Now, let's look at the wreckage. Before we close the loop on this $10 billion graveyard, if you respect the engineering that keeps the world safe, hit that subscribe button right now. Look at the aftermath of Operation Epic Fury. There was no chaotic crossfire. 11 core warships vaporized. Thousands of composite boats capable of 65 knots drifting lifelessly, completely out of fuel. The swarm didn't fail for lack of bravery. They failed because their thermodynamic equation was flawed. When American standoff range severs a 121,000-ton logistical stomach from hundreds of nautical miles away, the enemy starves to death in the open ocean. They die before they ever see the silhouette of the U.S. fleet. Epic Fury was the ultimate demonstration of the merciless calculus. The enemy tried to use cheap drone saturation to crush us, but they miscalculated American systems integration. We don't trade lives, we activate a closed kill chain. The Growler's electromagnetic blinding, the F-35C's stealth scalpel, the E-2D Hawkeyes digital quarterbacking, and thousands of pounds of kinetic energy from VLS-launched Tomahawks. But machines didn't execute Epic Fury. The kill chain was powered by thousands of American sailors operating as a single, synchronized organism. Dominance isn't just silicon and steel. It is the uncompromising discipline of an entire carrier strike group executing complex physics equations under extreme pressure. Real power isn't packing old explosives into cheap plastic boats. It is the ability to wipe out a $10 billion navy from hundreds of nautical miles away, entirely on our own terms. That is not battlefield magic. That is the absolute dominance of American math, geometry, and military engineering.